Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. BrCH2 12CCH is a terminal alkyne with a bromine at the other end of a 12-methylene chain, 14 carbons total including the alkyne carbons. Moving on to the next step. 9H2 is a strong base that deprotonates the terminal alkyne, pK-25, to form the acetylide carbanion BrCH2 12CCNA. This acetylide then undergoes intramolecular SN to displacement of the bromide by the carbanion end, forming a cyclic internal alkyne cyclotetradic 1-ene, a 14-membered ring containing a triple bond. This is product A. Moving on to the next step. Lindlar catalyst, PDCaCO3 poisoned with lead acetate and quinoline, performs S-ion selective partial hydrogenation of the internal alkyne. S-ion addition of H2 across the triple bond in the cyclic alkyne gives a CIS-Z cyclokene. In a cyclic system, S-ion addition means both H atoms are added to the same face, producing a CIS double bond, i.e., CIS cyclotetradic 1-ene, where the two ring chain segments are on the same side, Z configuration, and both newly added H atoms appear on opposite carbons of the double bond pointing to the same face. And for the final step, A shows a cyclokane, no double bond, incorrect, Lindlar gives alkene not alkane. B shows a cyclokene but the H atoms are both drawn on the same carbon of the double bond, suggesting a trans arrangement, incorrect for Lindlar. C shows a large ring cyclokene with H on the left vinyl carbon and H on the right vinyl carbon of the double bond, both pointing outward upward. This represents the CIS-Z internal cyclokene, consistent with S-ion addition by Lindlar catalyst. D is an open-chain bromolkene, incorrect. Therefore, the correct answer is C. Therefore, the correct answer is option C.